Welcome to Kanerika's podcast, The Digital Shift. If you work in enterprise data, you've probably noticed a really frustrating reality over the last couple of years.
Oh, definitely. It's pretty much everywhere right now.
Right, because we constantly see these general-purpose AI coding agents doing incredible things, like on standard software engineering tasks.
Yeah, they read local files, they write complex functions, they push clean code. I mean, it looks like magic.
Exactly. But then, the moment you point those exact same intelligent agents at your messy, highly governed enterprise data warehouse, they just hit a brick wall.
They really do. They start hallucinating table names, or they completely misunderstand the specific business logic.
But recently, purpose-built data tools have kind of shattered that wall. They've jumped the success rate on real-world complex data science tasks from 32.1% to a staggering 77.1%.
And that leap, up to 77.1%, it fundamentally changes the whole calculus of data architecture.
It really does. So today, our goal is to explore how Databricks Genie Code has basically altered the landscape of agentic AI for data teams. We're going to unpack the core mechanisms behind that success rate, the architectural shift that made it possible, and critically, how organizations must prepare for the immediate pricing implications hitting the industry right now.
Yeah, because if you look at why general-purpose coding agents fail in enterprise data environments, it's because they operate in a vacuum.
Right, like a smart intern who only answers direct questions.
Exactly. A standard coding assistant only sees the code repository you pointed at. But enterprise data teams, they require a totally different set of context.
They need the full picture.
Right. They need to understand intricate table lineage, historical usage patterns, evolving schema histories, and deeply specific business semantics.
And none of that institutional knowledge lives in a simple Python file.
No, not at all. Which is why the industry is shifting toward what you could call a proactive junior engineer model.
I like that analogy. So an agent that drafts the plan, writes the code, and basically just asks you for permission to deploy.
Precisely. And to understand how an agent achieves that autonomy, we have to look at the architectural shift that happened in March 2026.
Right, when Databricks sunset the old Databricks Assistant and brought in Genie Code.
Exactly. Because the old legacy assistant was entirely bound by that reactive intern model we just talked about. Its visibility was strictly confined to local context.
Meaning it only understood the code in the specific notebook you had open, right?
Yeah, just your open browser and your immediate chat history. You gave it a prompt, it generated a localized snippet of code, and then it just stopped.
It had zero awareness of what was happening in the broader data ecosystem.
None at all. But Genie Code changes that dynamic completely by operating as an autonomous workflow engine.
So if you give it a broad objective, it actually deconstructs the request into logical substeps on its own.
It does. It independently searches for the right data assets, drafts the code, executes it, analyzes the output, and if it detects an error, it just iterates and writes a fix without human intervention.
That's wild. But what's the underlying intelligence layer making that continuous loop possible?
What's Unity Catalog? Genie Code doesn't just parse text. It actively reads table semantics, it parses column definitions, and it traces data lineage backward through the pipeline.
And it respects the access policies across the whole organization, right?
Absolutely, across the entire data estate. And the way it processes that information is really fascinating, too. It uses dynamic multi-model routing.
Wait, meaning it doesn't just rely on one single giant LLM?
Nope. It dynamically selects the best model for the subtask. If it hits a really complex reasoning problem about data reconciliation, it routes that to a frontier LM capable of deep logic.
Oh, wow.
But if the next step is just, say, formatting a JSON output, it quietly routes that to a smaller open source model to conserve compute costs.
Okay, that makes sense for efficiency. But let me push back for a second. Generating generic SQL or JSON is the easy part, right? How does an AI possibly understand the twisted, super specific business logic of an enterprise?
That's a great question, and it's the exact hurdle that blocked older tools.
Because, every company has legacy tables with obscure acronyms and undocumented rules. How does it know that Table A should never be joined with Table B for financial reporting?
Well, because it's built natively on top of Unity Catalog, it isn't guessing. It actually reads the organization's governed metadata and its operational history.
So it's looking at historical usage patterns.
Exactly. It actively analyzes which tables are queried together most frequently by the senior data engineers. So the AI learns the institutional knowledge simply by observing how the human engineers successfully navigate the environment.
Wow. Okay, so knowing that Genie Code has this deep organizational context, The next logical question is, how do engineers actually interact with it to build systems?
It's structured through two distinct modes of operation. First, there's chat mode, which is optimized for single-turn questions.
So that's for rapid code generation, keeping latency low.
Right. It only transmits prompt metadata like table names and column descriptions, completely avoiding sending the actual underlying table data.
But the real shift happens when you toggle over to agent mode, right? Because that's the default setting where those multi-step autonomous workflows happen.
Exactly. In agent mode, it's granted the authority to read actual data samples, analyze the direct outputs of executed code cells, and auto-fix errors based on what it actually observes in the data.
And we are seeing this agent mode applied across 4 primary pillars of enterprise data work. Let's start with pipeline automation.
Yeah, this is probably the most immediate value driver. Genie Code integrates with the Lakeflow editor to generate complete Spark declarative pipelines.
Using a natural language description.
Yes, and crucially, it automatically implements things like AutoCDC.
Okay, let's pause and define AutoCDC for a second, because that is a massive cost saver.
Absolutely.
Change data capture, or CDC, means the pipeline only processes the newly updated records, rather than running a hugely expensive full table scan every single time. And setting that up manually is, well, it's notoriously tedious.
It is incredibly tedious, which is why having the agent handle it is huge.
Yeah.
It also packages these pipelines into declarative automation bundles, or DABs.
So basically standardized blueprints for version control and continuous deployment.
Exactly, without forcing data engineers to write thousands of lines of YAML manually.
Right. So automating the pipeline gets the data flowing. But the next massive bottleneck is always machine learning infrastructure, which brings us to the second pillar, ML workflows.
Right. Data scientists still spend way too much time wrangling infrastructure. Genie Code autonomously handles feature engineering, model training, and ML flow tracking.
But the real breakthrough is its historical awareness, isn't it?
It really is. When you ask for a recommendation to optimize a model, it physically reads the team's past experiments in ML flow. It looks at what failed in the past, so its recommendations are grounded in reality, preventing redundant work.
Which is brilliant. That brings us to the third pillar, BI dashboards. It can apparently build production-ready AI and BI dashboards from a natural language description, or even a hand-drawn sketch. But let me challenge this.
Go ahead.
Are you really saying a product manager can draw a bar chart on a napkin, take a picture, and the AI just connects it to a live data pipeline? Doesn't that bypass all our governance?
The capability to translate a visual sketch absolutely exists, yes.
Right.
But it does not bypass the engineering guardrails,
Okay, how so?
because there is a strict human-in-the-loop approval mechanism. Before Genie Code can modify an existing production dashboard, it requires explicit confirmation from an authorized user. It prevents unauthorized modifications.
Okay, so product managers can prototype rapidly, but the data engineers retain ultimate architectural oversight. That flows perfectly into the fourth pillar, GenAI debugging.
Yes, and this is critical because maintaining GenAI quality in production is incredibly difficult.
It's a nightmare, honestly.
Yeah. So Genie Code is embedded with Quotient AI technology. It acts as an automated debugger for other AI applications, analyzing agent traces in ML flow to fix hallucinations and tune resource allocation.
That is next-level infrastructure management. But, theoretical capabilities are fascinating. The true test of an agent is how it performs in a live, messy enterprise environment. And this is exactly what we at Kanerika focus on every single day.
Absolutely. Because we at Kanerika, we deploy these AI agents natively into governed production-grade data environments across various legacy industries.
Right, like that specific manufacturing case study we handled recently.
Oh, that's a perfect example.
The client had this urgent need for real-time inventory intelligence across highly distributed operations, but manual analysis was just way too slow.
Right. By the time the analysts pulled the CSVs and reconciled them, the insights were already outdated.
Exactly. So we at Kanerika deployed Carl, our proprietary AI data insights agent, natively within their Databricks environment.
And we tasked Carl with autonomously surfacing inventory patterns and flagging supply anomalies directly to the operations teams.
And the impact statistics on that were incredible. Deploying Carl resulted in 30% faster inventory reconciliation, 50% faster reporting cycles, and a 28% improvement in customer satisfaction due to much faster fulfillment decisions.
It really was a game changer. And, we often talk to clients about time to insight at Kanerika.
Yeah, we do. So Why was deploying an agent like Carl more effective here than just building them a traditional analytics dashboard?
Because Carl completely bypassed the need to build a custom analytics layer from scratch. It directly translated the complex data into plain language insights for the operations teams. They didn't have to interpret charts, they just got the operational answer.
That makes total sense. But achieving those kinds of results requires understanding that Genie code isn't magic, right? It has strict boundaries and governance realities.
Very strict. It inherits Unity catalog permissions entirely. It simply cannot access data the user isn't authorized for.
But what about that auto-approve feature? That sounds a little risky if not handled right.
You're absolutely right. Auto-approve is a heuristic productivity tool. It uses an AI classifier to execute what it thinks are low-risk operations automatically.
Right. Bypassing the human in the loop.
Exactly. Which is why it is not a hard security boundary. For highly sensitive production data, you must disable auto-approve. You still need manual review for consequential changes.
That's a vital reality check. And another reality check is how it stacks up against competitors, right? Like GitHub Copilot or Cursor.
Well, Copilot and Cursor excel in IDEs, for sure.
Yeah.
But they completely lack data and table lineage context. They don't understand the database itself.
What about Snowflake Cortex Code?
Cortex Code is a much more direct comparison. It offers incredible flexibility across the CLI, VS Code, and the UI. It goes very broad. Genie Code, on the other hand, goes much deeper into the data context, but it is strictly locked to the Databricks browser.
And that workspace lock-in is a huge hurdle. I mean, if an engineering team lives in their command line interface and local IDEs, doesn't forcing them into a browser just cause a massive disruptive change in how they work?
It's highly disruptive, yes. Genie Code has no CLI or local file system access. Plus, there is strict context isolation between chat threads. You have to start a new thread for a new task.
Right, or the context degrades. And aren't there limits on external tools, too?
Yes, there's a hard limit of 20 external tool integrations per session via the Model Context Protocol. So teams with spanning workflows will absolutely need a hybrid tooling approach.
Understanding those constraints is critical. But there is an even more immediate logistical constraint organizations must face right now, and that is the upcoming shift in the pricing model.
Yes, this is huge. Starting July 6, 2026, all Genie products transition strictly to a pay-as-you-go model.
And Databricks is giving an allowance, right? Something like 150 Databricks units, or DBUs, of free monthly usage per user.
Correct, which covers roughly 20 to 30 coding sessions.
Which is fine for an executive checking a dashboard once a week, but for a dedicated data team, they will burn through 20 or 30 sessions in days.
Easily. Heavy aggregate usage across a large data team will quickly accumulate massive cloud costs.
It's like test driving a luxury vehicle for free, but next month you start paying for the gas by the mile. If you haven't mapped your route, you're going to get a massive bill.
That is a perfect analogy. Organizations must configure Unity AI gateway cost controls immediately. We're talking hard spend caps, workload routing rules, all of it.
Which is exactly where our consulting team at Kanerika regularly steps in. We help clients model this consumption in advance and set up the necessary workspace governance so their billing actually remains predictable.
Exactly. Because you do not want to wipe out all your efficiency gains with a runaway compute invoice.
Absolutely not. So just to summarize this entire journey, agentic AI in data engineering is no longer just a concept. It is executing complex, governed workflows inside platforms like Databricks right now.
But its success relies entirely on underlying data governance, like Unity Catalog, and really understanding its operational boundaries.
Right. And whether a company is setting up that Unity Catalog structuring from scratch or modeling consumption costs ahead of July, we at Kanerika are here to help unlock the value of these intelligent systems.
The structural foundation you build today dictates your operational velocity tomorrow.
Which leaves us with a compelling final thought for you to consider. If AI agents like Genie Code can now autonomously build, test, and maintain robust data pipelines, the future role of the data engineer will no longer be about writing the code. It will be about architecting the overarching business logic and the strict governance that the AI relies on to function. So are your data foundations ready to be the brain of an autonomous workforce? Thank you for tuning in to The Digital Shift.